Okay, so let's talk a little bit more about frames and machines. You don't have any more homework on this, but this video is for you to go back and review for your exam. You may have something on your exam on this. So frames, the things I want you to know are how to draw free body diagrams of frames or machines and their members, and determine the forces acting on the joints or supports of a frame or machine. So take this reading quiz. You should know this. We went over these in class. So pause the video and then come back and we'll answer these. So frames and machines are different as compared to trusses, since they have at least one multi-force member, right? Trusses are only two force members. So if you don't know what those terms mean, you go back and define those first, but you should know that they're different because they have multi-force members. Forces common to any two contacting members act with blank on the other member. That answer is equal magnitudes but opposite sense. So if you don't know what that means, go back and look at your book. There's several things. So let's look at some frame problems. So frames and machines. This is a frame. This is a machine. They have two common types of structures that have at least one multi-force member. Trusses only have the two force members. Frames are generally stationary, meaning they don't move, and they support external loads. Machines contain moving parts and are designed to alter or affect the force. So similar to here, there's a lot going on in this machine. So steps for analyzing this. The first thing to do is draw a free body diagram of the machine and its members as necessary to find the global equilibrium first. Then we need to identify any two force members. There's none in this. Then we need to know that the forces contacting surfaces, usually between a pin and a member, are equal but opposite. So at B of the pin, we have FAB acting here and FAB acting here. So there's action and reaction. And for a joint with more than two members where an external force, it is advisable to draw a free body diagram of the pin. So FAB, we would have to do that. So we need to develop some kind of strategy then to apply the equation of equilibrium to solve for the unknowns, looking for ways to form a single equation of unknowns and single unknowns. So trying to make this as easy. These are challenging problems though, guys. There's usually several unknowns. We have to find the one that only has three, so then we can use X, Y, and moments. Mostly though, it just takes a lot of practice to develop good strategy and the ease of solving these problems. So let's do one. Let's look at an example here so that may help you. So the frame supports an external load, this 400 Newton force. The horizontal, we want to find the horizontal and vertical components at C and the magnitude of the reaction at B. So the first thing I want to do is draw a free body diagram, just BC. I'm not going to be able to solve this based on these both being pin connections, and then I'm going to apply the equations of equilibrium to solve for the unknowns at C and B, hopefully. So let's do that. B is a two force member, so we do know that. That's just a two force member that's coming out there. So we have a FAB here and FAB here. So if I draw that like that, this is how that will look. This is FAB. I have 800 Newton, I have CX and CY. So if I come and sum my forces in the X direction, well, first thing I'll do is not sum my forces in the X direction because I have two unknown X directions. I have two unknown Y in the Y direction. So the thing I want to do is either take the moments about C or B. Either will work. In this instance, I've chose to take in the moments about C. So the moments about C, we have 400 times 2 here. Then I have a negative 800 plus 800, I apologize, that's counterclockwise. And then I have FAB in the X direction, which is 3 over the square root of 10 times 1 meter. And then I have FAB in the Y direction, which is the 1 over the square root of 10 times 3 meters, because it's 3 meters from C. And that shows me that FAB equals 843.3 newtons. So then if I move to summing my forces in the X direction, knowing that this is 843.3, then I can sum my forces in the X. I have negative CX minus 843.3 newtons times 3 over the square root of 10. So that gives me 800 newtons, and it gives me a negative number. So I actually need to know that that's actually moving to the right. And then I have sum my forces in the Y direction. That will give me CY. And so CY is 133 newtons when I take negative 400, positive 843.3 times 1 over the square root of 10. I get 133 newtons up. And again, both of these I assumed the wrong direction, so they're actually pulling to the right and up. Okay, So let's look at some kind of concept quiz. The figures show a frame and its free body diagram. And if an additional couple moment is applied at C, then how can we change the free body diagram of member BC at B? So if an additional couple moment is applied at C, how would we do that? So the answer to this is A, there's no change. There's still just one force, FAB at B. So FAB doesn't change, even if I apply a couple moment at C. Okay, let's look at another one. Continue on this. It says, if an additional force is applied at D, then how will you change FBD? So this will have two forces, X and Y, because it's no longer a two force member. There's now a force at D in the middle. And so we have a multi-force member then. Let's do one more problem, hopefully. Okay, so with this problem, I have a wall crane supporting an external load of 700 pounds. And we want to know the force in the cable with which the winch motor and the vertical components of the pins. So we're going to draw free body diagrams of the frame's members. If I notice the FBD is a two force member, I can already see that. FAB is not, so I can draw this, and then I can draw these pulleys to look and see what those forces are there. And then I'll apply my equations of equilibrium. So looking at this pulley E, here we have 700 down, we have two ropes. So therefore our tension is 350 pounds in each of these ropes. Then if I go to my next pulley of just C, which a reminder, this is C. In that instance, I have a 350 pound force down, so 350 here. So then CX is 350 and CY is 350. Now if I look at my free body diagram of pulley B, which is here, which is again that 350 here, so this has to be 350. So then I can find BY and BX. I know this angle is 30 degrees. So BY is BY minus 350 cosine of 30. Which gives us 303.1, and then our X forces, we have negative BX plus 350 minus 350 sine 30, which gives me 175. So now I can come back and look at my free body diagram of FAC, which is here. So I have AX, AY, I have that 350 pounds and the 700 pounds at CX, and then at B I have the force from BD, that two force member. And then I have B, which I know BX and BY of this pulley that's also acting. They're 175 and 303. So I have multiple unknowns. The easiest way to take this would be either to take the moment at B or the moment at A. I chose to take it at A. So if I take the moment about A, I have TBD times the sine of 45 times 4. The X component's going to act through that, so I just have the Y component of that. Minus 700 times 8. So that gives me the tension in BD is 2,409 pounds. Then I can sum my forces in the X direction. So I have this AX minus TBD, which is 2409, times the cosine of 45, plus 175 minus 350. That gives me 1880. Then I can sum the forces in the Y direction. That gives me 303, 700, AY, and then TBD, which is 2409 times sine of 45. And so that gives me a negative 700. So AY is actually acting down. So AX is acting to the right, AY is acting down. So last but not least, if we wanted to look at BD, we have force here, and then we could find our reactions at D in the X and Y directions. That just becomes some very simple math. All right, so let's take a last quiz to see if you guys understand what's going on. So when we're determining the reactions at A, B, and C, what is the minimum number of unknowns in solving this problem? And take a minute, pause this, and read both of those. Okay, coming back on the first one, we're determining the reactions at joints A, B, and C. What is the minimum number of unknowns in solving this problem? The answer to that is 3. So that is actually D. And then for the above problem, if we have a free body diagram of BC, what will be the easiest way to write an equation involving unknowns at B? The easiest way for that is going to be to take the moments about C, because we have two unknowns there, and then we also get our BX force that will be eliminated. So then we just have one unknown, so we can solve for B right off the bat. All right, guys, that is that. Hopefully this will help you as you study for your test at some point.